So if we go through and predict, magnesium will go with the nitrate, and we'll end up with lithium by itself. That's not lithium. That's nickel. Okay. Is the magnesium nitrate balanced?
Yeah. No.
No. Nitrate is a -1. Magnesium is a +2. That formula is not correct. I need to put a 2 with the nitrate.
You're giving me a heart attack.
Okay. And since I don't really care about phases, I'm not going to include the phases. We should now decide, did the reaction occur? So we need to look for magnesium and nickel. There's nickel, and there's magnesium. Which one's the more active one?
Magnesium.
Magnesium. That means magnesium wants to be in a compound. Where's magnesium in a compound?
Product.
On the product side, which means
It did occur.
the reaction did occur. If we take a look at the next one, we'll go through and predict silver with our chloride, and then aluminum by itself. Is the silver with chloride balanced? Chloride is what charge? -1. Silver is +1. Is silver chloride balanced?
Yes.
Yes. Why are you saying no? I know why you're saying no, but I want to hear it. If we go to the other side of the equation, you'll notice that there is a 3 there. Why is that 3 there? To balance the chlorine with aluminum. When we go over to our products, the silver chloride, should I bring the 3 over? No, why not?
Because now you got to balance it with gold.
I have to
Or
balance
not
the,
gold, whatever it is.
the chlorine with silver. There's no more aluminum. So the formula is silver chloride with 1 of each. You have to be careful in transferring subscripts. The only time a subscript moves across is when it's part of a complex ion. Why are we allowed to move it then? That's part of what makes it the ion. Okay, we can't change the subscript then. When we look at aluminum chloride, that 3 is not there to make that chloride. It's there because there's 3 chlorides to balance out the aluminum. So be very careful on the meaning of your subscripts when you go through to balance. Which then brings up the next question before we even get into predicting if this reaction occurs or not. Is the equation balanced?
No.
So what do we need to do? We'd have to adjust our coefficients. I'm going to attempt to do this by just looking at it. And if we had provided the sum of the coefficients, we'd end up with 8 as our final answer. Okay? So as you go through and predict reactions, start to go back through and work on balancing at the same time. It'll help you progress. Does this reaction occur? Well, to decide, I have to go back and look at the 2 metals involved. I'm comparing silver to aluminum. Which is the more active metal? Aluminum. Where is aluminum in a compound? On the left-hand side, which means the reaction does not occur. I just went through and drew out and balanced all that. What the heck? That was all meaningless. Yeah, kinda, except it was good practice. Okay? Officially, all you would need to write for that would be no reaction. The last one will also be no reaction. Okay, and I'm not going to go through and explain that. Questions? Okay, that's our single replacement reaction. Okay, I will give you a condensed activity series. That's what's showing up in the upper left-hand corner, which some of you might see. Okay, so I won't give you the whole thing, but I'll give you a small portion of it for you to answer questions with. If for any reason you think I didn't give you a big enough activity series, or I didn't give you the proper elements, that's the time to raise your hand and be like, I can't answer this question because you didn't give me that information. Okay? And I might be like, yeah, I did. Or I might be like, yeah, you're right. I'll just give you the points. Okay? But I need to know. Don't just assume that you're missing something. Okay? Really quickly, there are some metals that are so active that when we drop them into water, they will go through and force a single replacement reaction. We are exchanging sodium as our metal with hydrogen as our quote-unquote metal from water. Okay. Some metals will pull it straight off of water, some won't. Okay. I don't expect you to have these memorized. Okay. They are relatively straightforward. It's pretty much everything in that first column. You drop those into water, they release hydrogen gas, and they produce sodium hydroxide, or the metal hydroxide, which is a really strong base. Okay? Usually a fun reaction to watch as long as it's not directly underneath you. Okay? But other than that, they're usually kind of entertaining. Ta-da! That's it. So now I apologize, because here's our slide shift, okay? Because I slid Chapter 8 around. So here's our movement. We're going to move to double replacement reactions. So here we've got, again, another type of equation that you must be able to predict the products for. Okay? So again, we're going to take our metals, and just like the single replacement, we'll exchange their locations. But instead of one of the metals now being by itself, it's now with another compound, okay, or with another ion. So we've got two reactions listed out here. We'll go through and do the first one together. Barium chloride. Symbol for barium is Ba. Symbol for chloride is Cl. Chloride is a -1. Barium is a +2. The charge does not balance, so I need to fix my formula by saying 2 chlorides. This is aqueous. Reacts with aqueous potassium chromate. That was mean. Potassium is a K. Chromate is CrO4. Chromate, hopefully, is what charge? -2. Potassium is a +1. Is our formula correct? Nope. I need a 2 next to the potassium. I know this is aqueous because it told me it's aqueous. This is now going to produce our products, and our products are going to be potassium with our chloride plus barium with our chromate. So all I'm doing is switching the ions. The only subscript that has come along is the 4 from chromate. Why do I bring that 4 across? That's what makes it chromate. I didn't drop the A on barium. Okay? I can't drop the 4 on chromate. Why do I drop the 2 on the potassium? 4 is a subscript 2. I don't accept that.
K2 is still potassium, so is K.
K2 is still potassium. It's just saying that there's 2 potassiums to balance the chromate. Okay. So now when I go through and look at my products, I've done the double replacement. Now I need to make sure those formulas are correct. The charge on potassium is a +1. Charge on chloride, -1. Is that formula correct? Yeah. Barium is a +2. Chromate is a -2. That formula's correct. Balancing out the overall equation. I'm going to zoom out a little bit here. I need a 2 here. Oh, did I just do it? Yeah, I just did it. Okay, there it is. Okay. We just need a 2 in front of the potassium chloride. And here's the extra rub on this. Actually, no, let's leave that off. Go through, work on the last one. I'll give you 2 minutes to get that last one balanced. And then we'll add the last line on your paper is exactly what's written up there right now. Yes. Okay. Any questions about what's up there? Everybody's good with it? Couple extra things we're going to throw in there. Number 1, does the order of which product you've shown first matter? No. Addition is additive, clearly. Commutative. So it doesn't matter the order in which product you show. But as Charles started to allude, we are missing some extra information. In our reactants, What do we have as extra information that the products have not shown? The physical state. What is the physical state of potassium chloride? It is aqueous. What is the physical state of barium chromate? It is solid. What is the physical state of lithium chloride? It is aqueous. What is the physical state of sodium nitrate? It is aqueous. Okay. How does this allow us to then decide, did a reaction occur? Well, in the first case, did a reaction occur? The barium chloride reaction. How do you know a reaction has occurred? Change in physical state. We have a solid formation. A reaction has occurred, a chemical reaction. How about the second reaction? No. There's no phase change, which means there's no way to decide that a chemical reaction has occurred. Okay? So then bottom one is a no reaction, the top one is a reaction. So if you were expected to go through and predict your products and balance accordingly, the only one you would really be dealing with is the first one, not the second one. Okay. So was that the two hands? So I just went through and wrote down what the phases were. How the heck did I know what those phases were? I wrote the slide, so that's the first thing. But the second thing is that you need to have a rule set to explain why you have a solid versus not a solid, or why you have a solid versus aqueous, okay? Which is going to come down to solubility. Some compounds are soluble in water, others are not. How would we figure that out? You would test it, much like we did with the single replacement reactions. How did we decide a reaction occurred? We either tested it, or we looked at an activity series to tell us whether it should have occurred or not. We're going to do the same kind of thing with the double replacements, except it's a whole lot uglier. Okay? What we are going to reference are our solubility rules. And let's ignore that. Our solubility rules. So if we take a look at our first equation, let's decide how could we possibly figure out the phase that barium chloride is aqueous. Well, I need to go back to my rules and look for either barium or chloride. Do you find barium or chloride anywhere in your solubility rules? Find barium or chloride in your solubility rules? According to rule number 4, yes, it's there. All halide ions, okay, well that's not very helpful, it just says all halide ions. Reference the heading. Any ionic compound containing a halide ion is soluble, which means aqueous. Okay. Notice that after it says halide ions, and it lists what the halides are, it then says silver X, HGX, and PBX are exceptions. Okay. So before we panic, barium is that silver, mercury, or lead? No. So it's not an exception, which means barium chloride is aqueous. What about potassium chromate? Where do we find potassium or chromate in our table? So it's going to show up in a couple different places. We'll see chromate down here, which I'm going to point at first. Chromate ion, look at its heading, are generally insoluble, which means the phase is solid. But according to our rule, or our equation, it says it's aqueous. Why is it aqueous? Read the rest of line 7. See Rule 1 for exceptions, which are soluble. Rule 1, alkali metal ions and the ammonium ion are always soluble. Notice how many exceptions follow Rule 1.
No exceptions.
There are no exceptions. Those other numbers are for different compounds. There are no exceptions to rule number 1. Lithium being a group 1, or lithium is a group 1 metal, but potassium being a group 1 metal, will make that compound water soluble. Move to our products, barium chromate. Where do we find barium or chromate? We got our chromate rule, rule 7. Exceptions which are soluble, what were our soluble ones? The alkali metals, so group 1 metals, and ammonium ion. Is barium any one of those exceptions? What does that mean? Barium is a solid. There's our phase. So every time you do a double replacement reaction, you have to go back and reference your solubility rules. This can be a very tedious and time-consuming process. Okay? Should you go through and memorize them? I think it is a complete and utter waste of time to go through and memorize them. However, I do have 3 rules memorized. Yes, 3 rules. What are the 3 rules I have memorized?
1, 4, and 7.
1, 2, 3.
That's supposed to be used for these.
Why did I memorize rules 1, 2, and 3?
Because those are the smallest, they don't have any exceptions.
No exceptions. That's it. Everything else has an exception. I don't want to memorize a rule to find out that there's 20 exceptions. Okay? So I memorized the ones that have no exceptions. That can get you through most of a question by just following those 3 rules. It's not perfect, but it gets you pretty darn close, particularly in a multiple choice situation. Okay? After that, I will give you some limited solubility information for exam 3. So again, take a look at the cover page of your exams. You'll notice there's a little section that says solubility rules, and you might wonder, why the hell is he giving solubility rules? For this. This is why you have that on there. Okay? Questions about that? That sounded like sarcastically. Nice.
It is an extreme.
I couldn't quite figure that one out. Questions about that? Okay. I am not going to start chapter 7 yet, or 17, but I do want to finish neutralization reactions. Neutralization reactions are the same thing as your double replacement, okay? Except you're mixing specifically an acid with a base. How do we know we have an acid? You see the hydrogen and officially aqueous. How do we know we have a base? You're going to be looking for specifically hydroxide. The products of an acid-base reaction will be water and an ionic compound. Okay, whatever else is left over. That's it. Okay? So let's take a look at this real quickly. Predict the product of the complete neutralization, complete being the operative word here, of sulfuric acid with potassium hydroxide. Formula for sulfuric acid would be H2SO4AQ, so pretty good on the HSO4s there. Why is it H2? Sulfate's a -2, hydrogen's a +1. I need 2 hydrogens. Potassium hydroxide, KOH, aqueous. This is going to go through to produce potassium and sulfate, and you'll notice that I write it as HOH and not H2O. Why am I doing that?
Not making water.
You are making water.
This is not like that on the other side.
All it's trying to do is call attention to the location of where the H and the OH came from. This can become helpful if, say, you need to balance the equation, because now we can balance hydroxide. If you write it as H2O, you can't balance the hydroxide, at least not as obviously. Is this formula correct?
Yes.
Sulfate is a -2, potassium is a +1. Is the formula correct? What do we need? 2 as next to our potassium to go through and balance. And we're now balanced. One last thing before you guys run out of here. I know you're super excited to go to lab. The subscript 2 in front of sulfuric acid. Notice It does not show up in our product. Why not?
Because it's
Not
The
sulfuric
2 from sulfuric acid is to have the hydrogen balance the sulfate. There is no more sulfate in HOH. The 2 does not come across as a subscript. We still have to account for it, but we'll account for it in balancing the equation, not the formula. Okay? I think there's one more example on neutralization. I'm done. Okay. Let's see. Is there? Nope, there isn't. So we'll be starting chapter 17 on Tuesday, which is a bit of a doozy. If you read ahead, no more than the first 2 sections. Do not read more than that.